Okay, isosceles and equilateral triangles. So we're going to take a break kind of from triangle congruence and talk more about two special types of triangles that we have. So isosceles triangle is any triangle with two congruent sides. You good?
I'm good.
So two congruent sides and an isosceles triangle. So we call those congruent sides the legs. The angles that are opposite those legs, so, right, remember opposite means if I draw a line from the other side, so those are the opposite angles. Those are my base angles. And then the shaded one up here, should have left it longer. Sorry, that blank is terrible. That is my vertex angle. You're not gonna write anything either?
What?
You're not gonna write anything either?
I will. We don't even really use these though.
You can use them on your test.
I know.
Alright, so isosceles triangle, they have a couple properties. So if the two sides of the triangles are congruent, whatever angles are opposite those sides, those are also congruent. So, because these two sides are congruent, it means the angle's opposite, so angle A and angle C are also congruent. So that's just a general property of isosceles triangles. It works the opposite way. So if two base angles are congruent, the sides opposite those are congruent. So because A and C are congruent, the sides opposite, so AB and BC are congruent. Focus, gentlemen. I'm just making a blanket statement to the three of you. All right, so those are just kind of properties. All right, last property we have is that if a line bisects the vertex angle. So, refresher, what does bisect mean?
Crosses the middle.
Crosses the middle, splits in half, right? It makes things in two halves so they're congruent. So if it bisects the vertex angle, so if it bisects this angle up here, the line is also the perpendicular bisector of the base. So when I say perpendicular bisector, what I mean by that is that I also bisect this base. So AC is bisected, but I meet at a right angle. So there's another property that'll be keyed up. So if you see it's bisected up here, means I can make a right angle, and I can bisect this. Make sense? Questions, property?
I don't even know what's the difference.
Okay.
Between isosceles and equilateral.
So let's read theorem. Let's read this right here. If the two sides of a triangle are congruent, then the angles opposite those sides are congruent. Those are the base angles. So the base angle. Look at examples. Okay. So first two, we're still looking at isosceles triangles. So we look at the first one, right? I want to know what is A right there. So what do you notice about that triangle? What's labeled down there?
B and AB.
Okay, so I have two congruent sides, right? So what type of triangle do I have? Isosceles. So isosceles triangle, and what are the base angles of an isosceles triangle? They're always what? Base angles of an isosceles triangle are always congruent. So
A, B, B, C are congruent, meaning that AC is congruent too. Right?
say that one more time.
CB and BA are congruent, meaning that AC is congruent.
Not that
So
A,
those two are congruent.
do you mean AC the side or AC the angles?
The side.
Okay, so not the side.
The angles.
It's the angles. So because these two are congruent, the angles opposite those, yeah, the angles opposite those are congruent. So the measure of angle A is 70, right? We're always talking about, did everybody get what I mean by when I say the angles opposite those sides? So if I draw a line from the side to the angle, that's the opposite angle. So there's one type of question. Now let's say that if they wanted to find B, what would I need to do? So say I wanted to find,
180 minus 140.
yeah. So if I wanted to find B, use that fact that triangles add up to 180. If that also asks that. All right, cool. So if I look at this one, so we can start by labeling some things that I know. So what type of triangle do I have?
What do you think is the difference of isosceles and equilateral? Like, that's what I don't get.
Okay, so isosceles only has two congruent sides.
Two congruent sides.
Yep.
And equilateral,
We'll have all three.
all three.
Yep.
So it's isosceles.
So it's an isosceles because I have these two congruent sides. So what one of you here tell me what angle in that triangle is going to be congruent to what other angle do we know? Anybody know? Want to write it on here?
42.
So which 42? Write it up there for me.
Oh, okay.
You get to play on the tablet.
Okay, everybody agree with Dylan?
Yes.
That's 42?
Yes.
Okay, cool. So now I want to look at, do I know any other angles
Yes.
that aren't labeled? Which one?
The right angle. Right where the X is. Find it.
Show me what you mean by right where the right angles are.
Right about here.
Okay, so
Screw
why
up a
are
little
those, somebody tell me why Alex said those are right angles.
That's gonna bisect the vertex.
Yeah, right? Remember we had that other theorem that said if I have a bisector up here, it meets at a 90-degree angle down here. So now could we find x?
Yeah.
So what would be the equation I set up to find x? Well, I want to do it that way because otherwise I end up with a negative number. Yeah. So whatever 180 minus 42 minus 90 is, so basically what's 180 minus 132, right? Anybody know what that is? 48 equals x. Make sense? Questions about what we did there? All right, equilateral triangles. So these are triangles where all the sides are congruent. So when I have all the sides congruent, it means all the angles are congruent. And they all have to equal 60. They're all 60 no matter what. An equilateral triangle.
Like a scalene triangle.
Yeah. Scaling is no sides congruent. So there's no special properties to those ones.
We don't really know.
Yeah, so we don't really, I mean, you see it, like everything a lot of what we've done, we talk about triangles adding to 180, generally you're looking at scaling triangles. But that's the only real special property they have. So it also goes the other way. If all the angles are congruent, then all the sides are. So it goes the same way. So if you know all the angles are congruent, you know all the sides are. Sides could be whatever length. That doesn't matter. You could have an equilateral triangle that's 20 inches long, and you have one that's 2 inches long. So the sides are never going to be some length, but the angles will always be 60 degrees. So these ones, if you're looking at an example, right? If you know the sides, you're setting them equal to each other. I didn't do an example like that because we've done a lot of that. If things are congruent, we set it equal to each other. So the other thing here is, well, what did I just say that all the angles had to equal? 60, right? So if y minus 10 is an angle, you can write that as an equation. So what would that angle, or what would y be? 70, right? I'm going to add 10. Y equals 70. I do the same thing with x plus 5 because I know that has to equal 60. And so how do I solve for that one?
X plus 5 equals 60.
Yep.
Oh, I didn't see it. E minus 5.
Subtract 5.
X equals 55.
So x equals